Assalamualaikum warahmatullahi wabarakatuh and good day everyone. We are here to present our final project for NMK 3703 programming for networking. Our team has developed a secure multi-client chat application that built using Java socket programming. My name is Siti and I'm joined by my teammates Farah, Maisarah and Aqilah. Okay, so for now, to ensure a successful development life cycle, we divided our responsibilities into specialized roles. Farah was as our server architect, and me was the lead coder and UI developer, and Maisarah served as our security lead, and Nurfatin Aqilah was manage our documentation and development operations, which is stand to DevOps via GitHub, and this modular approach allows us to work on the server, security, and interface in parallel. Okay, so for this slide is about our project objective. So our project is based on 4 main objectives. As first, we build a multi-client server using Java sockets to handle many users at the same time. Secondly, we add access control to verify the user credentials before they can join the chat. And thirdly, we ensure the data security by implementing AES, that encryption for every message sent. And finally, we develop a graphical interface GUI to make the application user-friendly and easy to use.
My name is Farah Nuralissa and now I will explain about our system architecture. Now let's look at the heart of our application, the system architecture. We implemented a centralized server model. In this setup, the server acts as the intelligent hub for all communication. Technically, the server is configured to listen on port 12345 for any incoming connection request. Client also can join the secure bubble using either a localhost address for testing or a specific IP address over a network. To ensure the application is responsive, each individual connection is managed by a dedicated background thread. This allows the server to perform its primary task, which is receiving an encrypted message from one user and also routing or broadcasting it to all other active clients in the real time. Moving into Module 1, we focus on the server implementation. As the lead coder, my focus here was to develop a backbone that is stable enough to handle the concurrent communication. The server isn't just a relay, it is responsible for managing user states, handling the authentication gate we discussed earlier, and also ensuring that the network stream remain open and healthy throughout the session. This module is the foundation that makes multi-client interaction possible. A major requirement for this project was handling multiple clients simultaneously. To achieve this, we utilize thread per connection management. We use the server socket.accept method to listen for new user. The moment a user connects, the server doesn't stop to talk to them. Instead, it spawns as a new client handler thread. This is a crucial engineering decision. It prevents the server from blocking. Because of this threading logic, if user A is sending a large encrypted message, it will not cause a delay for user B. This architecture fulfills our simultaneous handling requirement perfectly. Next, let's look at how the data is actually managed. To keep track of every active user, the server maintains a hash set of print writer objects. We use synchronized blocks within our code to manage this list. In a multi-threaded environment, two threads might try to update the user list at the same time. Synchronization prevents data corruption and race conditions. Lastly, we implement a graceful error handling. If a user closes their window or loses their internet connection, the server detect the broken socket, remove them from the broken list, and clean up the resources without crashing the entire chat for everyone else. This ensures high availability and system stability.
My name is Maisarah and now I will be presenting on Module 2 Security and Encryption. This project security framework includes AES cryptography. We use a symmetric key which is NMK 30703 underscore project to encrypt outgoing string and then decrypt incoming base 64 data. This satisfies the engineering tool requirement by employing standard Java cryptography architecture JCA libraries. In this project, we have three main engineering tools. First, we have used NetBeans Integrated Development Environment, which for the core development environment to building and debugging Java components. And second, we have used GitHub, which is used for version control, code management, and team collaboration. And lastly, testing, rigorous multi-instance testing to verify broadcast and encryption success.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfatin Aqilah binti Azmi. So next I will present the result of our server initialization. So first, we started the chat server and the server successfully initialized on port 12345 as shown in the console output. So this indicates that the server is active and ready to accept incoming client connection. So before implementing the chat features, we also tested our AES encryption and decryption functions. So the console output shows the original message, which is the encrypted ciphertext, and also the decrypted message. So since the decrypted message matches the original plain text, it confirms that our encryption modules is working correctly before integrating it into the chat application. So this slide demonstrates the multi-client communication features on our application. So two client instances named Ali and Abu are connected to the same server through localhost. So after both users successfully log in, they were able to exchange message in real time. So as shown on the screen, when Abu sends the message "Hello Ali," so the same message immediately appears on Ali's chat window. So this proves that our server is capable of broadcasting message to multiple connected clients simultaneously, which fulfills the requirement for multi-client socket communication. Okay, so this slide demonstrates the security implementation in our secure chat application. So we actually implemented AES 128 encryption using a 16-character secret key to secure all the messages before transmission. So every message is encrypted at the sender side and transmit through the network as encrypted ciphertext and the decrypted only by the authorized recipient. So the server console shows both the encrypted message received and the decrypted version used for verifications. So this demonstrates that the transmitted data remains unreadable while traveling through the network. So ensuring the confidentiality and protecting the communication from unauthorized access. So finally in this slide, summarize the overall functional verification of our project. So first, the server was successfully initialized and started listening on port 12345. And next, the client handshake process was verified, which allowing authenticated users to connect successfully and display an online status. So we also confirm that the AES encryption and decryption functions work correctly to ensuring the secure communication between the clients. So lastly, our broadcast messaging feature was successfully tested where multiple connected clients receive messages in real time. So overall, all the main objective of our secure multi-threaded chat system were successfully achieved.
In conclusion, this project taught us the vital lessons in handling trade safety, managing network latency, and implementing industry standard encryption. However, by utilizing tools like NetBeans and GitHub, we were able to resolve a complex deadlocks and deliver a secure and plus the functional application. So that concludes our presentation, and thank you for watching and listening to us.